Hey there, welcome to Astro Talk.
I'm your host, Maya, and today we're diving into the frosty seas of Titan.
That's Saturn's biggest moon, right?
Exactly, and it's got liquid on its surface, though not water, but methane and ethane.
So why is that interesting for life?
Because scientists think those hydrocarbon lakes might be creating tiny bubble-like structures that resemble the first cells ever formed.
Bubble-like structures? You mean vesicles?
Yes, vesicles, small compartments with a membrane that can hold other stuff inside. On Earth, we see them made of lipids and water.
How would that happen on Titan?
The trick is amphiphiles, molecules with one side that loves hydrocarbons and another that doesn't. They naturally line up at the surface of liquid methane or ethane.
And what triggers their assembly?
Imagine rain droplets falling into a lake, splashing up spray droplets. Those droplets get coated in amphiphiles on both sides, one from the droplet itself and one from the lake surface.
Then what?
When a sprayed droplet lands back on the lake, its two layers meet and fuse into a bilayer membrane, trapping a pocket of liquid inside. That's your vesicle!
So it's like a soap bubble made of methane?
Pretty much. And because Titan is cold, around minus 180 degrees Celsius, these structures can be surprisingly stable over long times.
Why does that matter for life?
Vesicles are the first step toward protocells, which could evolve to compete for resources and maybe develop metabolism. They're a key piece of the origin of life puzzle.
How did NASA find this out?
Researchers published their model in the International Journal of Astrobiology using data from Cassini about Titan's atmosphere, chemistry, and liquid cycles.
Does Dragonfly know about this?
The upcoming rotorcraft will study Titan's surface composition and atmosphere, but won't directly detect vesicles. Still, its findings could help us understand where such processes might happen.
So the takeaway is that life-like chemistry might be brewing in alien lakes?
Exactly. It shows that complex organization can arise even in a very different environment, methane instead of water, and gives us new targets for future exploration.
Fascinating stuff! Thanks for breaking it down, Maya!
Anytime! Tune in next week when we talk about Enceladus' plumes and the possibility of life beneath its icy shell.
Until then, keep looking up at the stars. Who knows what else is brewing out there?